welcome you all to ninth week's problem solving session for learning analytics tools. Um, so there are 7 to 8 of us in the meeting. Attendance is 9. 2 out of 9 are my IDs. So wait for a minute or let's begin. I'll let others join. Yeah. So this week also we are continuing with the predictive analysis. Uh, so last week also we saw predictive analysis, and this week also we will be seeing two more techniques of last week we saw regression. This week we'll be talking about naive Bayes classifier and decision trees exclusively, like two of the prediction machine learning techniques. But we will not be going into mathematical modeling involved in all these techniques, but in short we'll try to understand how these are performed, and we'll try to interpret the results. Yeah, so many of the concepts of result interpreting we have already done in previous weeks, and major application of knowledge would be applying the Bayes probability theorem to predict the classes when we are using naive Bayes classifier to predict the classes of our using our data. So we will be using the Bayes probability theorem for this, and decision tree has new concepts of entropy and information gain. So we'll quickly revise that. I'm going to assume that you all have watched the lectures and come for today's lecture. So if you have watched, then you would already know about the naive assumption, why naive Bayes classifier is called naive. So because we have this naive as in very simple, we are simplifying the complications by assuming that the features are independent of each other. So when we say features, we mean the features which we are generated based on our learners log data. Yeah, so these features may include their attendance in classes, the assignments which they are solving, their performance in tests, and so on. So all these features, they might not be always independent. Yeah, these features may not be always independent of each other, but we are going to assume that these are independent. That's why the name of this classifier is naive Bayes classifier. Yeah, so we will be using this particular theorem to do probability calculations. This is if you can recall it from previous classes, this is conditional probability. Yeah? Probability of event A given B has already occurred. B has occurred. Similarly, this is probability of occurring B when B has already occurred. Yeah, so this is nothing but conditional probability. So we will not be going into derivation of this theorem, how this came. We will not be going into that, but instead we'll be focusing on using this particular formula, okay, for our even the assignment this thing calculations. Yeah, so this is conditional probability formula, which is fairly straightforward to use. We just have to interpret the problems to decide what condition for which probability condition we are supposed to calculate the probability and so on. So interpretation of the question plays important role there. Okay, so while in decision tree, do you recall the classification methods of agglomerative classification? There was Agnes, hierarchical classification technique. Yeah, you remember there was top down approach, bottom up approach, where we had these classes which were further getting classified. Yeah, like that. So these decision trees are very similar. They are like yeah, the root and leaves. So similar structure we will follow. So it's basically rule based system we have. Like there would be one condition, one rule. If attendance percentage is greater than some 50%, sorry, is less than 50%, greater than 50%, then there would be some another condition based on its possible values. Yeah, then based on some other condition based on that particular condition's possible values. So how do we classify or predict that's the decision tree. How do we make decision where a particular student or given set of features will be classified into which category, that will be output of this decision tree. So one decision tree, when we combine many decision tree, it becomes random forest. As the name suggests, one है single tree, multiple trees will constitute a forest. So random forest techniques also follows this rule based division of prediction of classes. And how do we decide which node to be at the root, which node when to stop the further classification, when to which node will be the leaf node. So all these things are decided based on these two parameters, entropy and gain, information gain and entropy of that particular column or that particular feature. So entropy formula is summation of minus pi of log pi. So pi would be probability of that particular class or that particular feature with respect to what is our dependent feature. So dependent feature is like we want to predict their performance, we want to predict their marks in the final exam. So that would be independent feature. So how many of our students will have marks greater than 80 and less than 80? So we have two classes, greater than 80 scoring and less than 80 scoring, and that would be our dependent feature. And independent feature this is independent feature probability. So independent feature may be different, like percentage of attendance then what else, the number of assignments and so on. So that could be it could be their probability, like the different classes of that particular probability, and then what is the probability of scoring 80% and less than 80%. So even if right now this looks confusing, once we go to solve the problems, these formulas will be a bit clear. Okay, so don't worry. And when such questions, if they are coming for the exam, you will be allowed to use calculators mostly. So don't worry, carry your scientific calculators with you, where you can calculate the log, and this log is always calculated to base to the number of classes. So if our pass and fail are two classes, so it will be log to the base to 2. Yeah, so this thing is also explained very nicely in the lectures. Yeah, so similarly for information gain for a particular feature, again set of feature or a column in our data set, so we already know how to get to this entropy. We do it for this thing, independent and dependent variable. Based on that, I'm sorry, I think I wrote it not independent, it is dependent, probability of what is the distribution of your data set according to dependent variable, that's probability. Yeah, I'm sorry. Yeah, now it looks better. Yeah, so now this entropy we'll calculate using this formula, and this is number of items which are belonging to that particular independent feature. Yeah, so this would be number of items belonging to the class of independent feature. And respective entropy, and this will be total n. So this will be probability, or this will be the probability calculations. Yeah, so even though this formula looks confusing, we'll take it up when the problem comes up. Okay, so in order to ease the calculations, we should remember this entropy graph. So based on the probability value, this is the probability value and this is the entropy. H is entropy value and this is this probability. So this entropy gives us the nature of randomness in our data. If our data is random, because for decision trees we have to account for the randomness, because we want to account for the rules, which will give us the maximum entropy. We want to go with that, or which will give us the maximum information gain matlab data loss, the minimization of data loss, information loss. So we'll try to preserve those nodes. So for that, this entropy calculation plays important role. So you can see the distribution of entropy in this graph. So for probability is equal to 0 and probability is equal to 1, the H value or the entropy value is 0. Over here you can see, and it is maximum for 0.05. Why? Because mostly we deal with the two classes, and when you calculate half log to the base 2 half, that gives the maximum probability. If you observe this formula closely, you will get your answer that y for 0.5 or 1/2 it is maximum, and y for 0 and 1 it is minimum, because of this log function. So we have to remember this minimum value for entropy for probability 0 and probability 1, p value 0 and p value 1, and it is maximum for p value 0.5. Okay, so if we remember these pointers, then probably even in the exam, if the question comes, you will be able to solve it, in most of the cases. So let's move on to the questions. So I'll read out the question, and so this question is for a Bayes theorem. Okay, it's based on conditional probability, so we have to be very careful while interpreting this particular question. Okay, so let's read very carefully. So in a course, 50% of the total students have attendance greater than 80%. Okay, so having attendance greater than 80%, let's call this condition A. Now 10% of the total students have scored marks greater than 80%. Okay, scored marks greater than 80%. Now it says 50% of the students who scored greater than 80%. So scored greater than 80% is condition B. Who scored greater than 80% already have the attendance which is greater than A. So this is greater than 80%. So that means this 50% of the students. So if we want to put it into this formula, like given A and B has already occurred, so likewise, like this is the probability of so this is the probability of B, who scored 80%. Probability of B given A has already occurred is 50%. So in terms of probability, this is 0.5, and probability of A is 50%, so again 0.5. Now probability of B is 10% of the total, so we will convert this percentage out of 100 into out of 1. Probability of B is 0.1. So now now what is the chance of a student having attendance greater than 80% to score marks greater than attendance greater than 80% to score marks greater than 80%. So that means probability of A when B has already occurred, na? What is the chance of student having attendance 80% where he already has score of this thing, no? So this we have to find out. Okay, let us interpret it once again so that we don't get confused between A and B. Okay, so probability of attendance, we are calling it as condition A. Then probability of having score greater than 80, condition B. So there is a 50% chance that student who scored greater than 80% have attendance greater than 80%. Now what is the chance of student having attendance greater than 80% to score greater than 80%? Okay, ठीक है. That means this is wrong. Okay, this is probability of A already given B. Yeah, so students who have already scored greater than 80% and they have attendance of greater than 80%. Okay, so even I made mistake in interpreting. Yeah, so this is B has already occurred. Okay, who has scored greater than 80%. Now our main event is A, which is attendance having greater than 80%. So attendance was A. So this is probability of event A given event B has already occurred. Okay, given they have already scored 80%. Yeah, so that's why it is A by B. And probability A. Yeah, does it make sense now? Probability of attendance having 80% and for them to have score greater than 80%. So B by A. So now let us go back to the formula. What does the formula say? Probability of A by B is equal to probability of B by A into probability of A divided by probability of B. So let me write down here, A by B is this into probability of I think B by A, A by B, A by probability of B. So we will do the substitutions. So this implies 0.5 is equal to probability of B by A multiplied by 0.5, which is probability of A, and divided by 0.1. So if we adjust everything, we get, this goes 0.1, which is, if we convert back into percent, should be 10%. Yeah, so it is all onto interpretation of the problem. Okay, so let's again cross check that we have not made any mistake in the interpretation of question. Okay, so attendance greater than 80% is condition A, and marks greater than 80% is condition B. So now 50% what they have given is students who have scored greater than 80% and they already have attendance they have scored greater than 80% and they have attendance greater than 80%. So attendance is A, right? So probability of event A, that they should have what is the probability that they will have attendance greater than 80% given that they have already scored more than 80%. So yeah, this probability of A by B, this is 0.5, so this is correct. Now what is the chance of student having attendance greater than 80% so that the score is more than 80%? Yeah, so probability of B we have to find. Yeah, A is already given. Chance for a student who is already having attendance greater than 80%, and what is the probability that such student will score marks also greater than 80%? Yeah, so this would, what is asked us is probability of B given A. Our B is scoring greater than 80%, and our event A is which is already done by student is having attendance greater than 80%. So we put everything in the formula and we get the answer. Yeah, fine, we'll move on to next question. Okay. So entropy formula is already given here. So entropy for node S we have to find, now where pre is probability, C is number of classes, and entropy is maximum and minimum values are achieved at. So we have already discussed this. So can I have answers in the chat box, or unmuting and answering? That is also good. When will the maximum value occur, and what is that maximum value of entropy? That also please tell me. And when will the minimum value, at what value of probability will be occurring? We have discussed this when I was showing that entropy wala graph. Okay, I have got one answer, two answers. I'll wait for few more seconds. It's not possible that out of 20 just 2 people were were paying attention. That's not possible. Yeah, finally I've gotten third answer. Okay, great. So all of you have answered option A, which is correct answer. If you recall this graph, this is the entropy graph for value for probability 0 and 1. Because we are calculating log of that value, this will give us the value of 0, and it is maximum for the 0.5, which is 1. Yeah, because entropy gives us the idea about how random our data is. It gives us idea about the randomness of that data. So when we have highest probability that our data is going to be belonging to that particular class, that means we have probability of 1, so it will be 0, the entropy will be 0. Yeah. And when we have probability of 0.5, that means our data has equal chances of belonging to every I mean, out of 2 classes, our data has a chance to equally belong to both the classes. So in that case, the randomness in our data will be maximum, or the entropy will be maximum. That will be 1. Okay, so in simple words, if you want to remember this, like why it is maximum for 0.5 and why it is minimum at 0 and 1. Okay, so Vinuta is saying there is a break in my voice. So is it for everyone? My internet connection seems fine. So if it is for everyone, I will try to change the internet source. Okay, it's not now. Okay, fine. So let's move on. Let's not discuss about this anymore. Yeah. So if there is any problem, please let me know in the chat box. I will try to change the internet source. Okay. So we'll move on to the next question, question 3. Okay, so this question is related to decision trees. Now, overfitting and increase in the tree complexity can be overcome through the process called. So, if you have watched the videos, then this is very easy answer. If you have watched the videos, then okay, I'm getting all the correct answers. Pruning. So, should we briefly discuss this? That why it is pruning and what is consisting in pruning. So I'll briefly cover. So what happens is, since this is a rule-based system that works in creation of decision trees, so when our training data set will try to optimize the so it is a greedy algorithm. The decision making decision tree is called greedy algorithm, because they will try to optimize based on what data you give them for training. Based on what they have, they will try to create a model which is optimum for your given data set. They will not worry about the randomness of the data, randomness which the data can have, or the possible values which your data can have. It will not worry about that. It will worry about what data they currently have and how to best fit that particular data in the given decision tree using the set of rules. That is what the tree the decision tree will the decision tree model will look out for. So in such cases, the overfitting is very common. Overfitting mane, if you have the testing data, training data set, if you have the training data set, it will try to create the best fit based on your training data set. So when you have the test data, which is not part of, or which could be subset of your training data set, like n-fold validation and all those things. When that happen, when the training data set, a part of training data set you give as you pass on as the testing data set, so in such cases the prediction is very accurate because that is already been used for training data set. So such problem is called overfitting problem. Yeah. So how to overcome overfitting and complexity, again same, it will try to come up it will try to optimize the nodes and the branches of the trees accordingly, according to data you have. So it may create unnecessary nodes to accommodate each and every data set in properly into the tree. That's what it mean by increasing complexity or greedy algorithm. Yeah, it is because it's greedy algorithm. Yeah. So how to avoid that? So there is a way to avoid that, or way to overcome this particular greedy problem, or this particular increasing complexity wala issue. So what we do is pruning. As the name suggests, when we prune the tree, what do we cut? We cut some new leaves of that tree. So that is what is done. We will remove the least significant nodes from that particular tree, which will not give us much of the information regarding the classification. So we will remove such nodes from the tree, and we'll try to accommodate we'll try to reduce the complexity of decision making for a particular tree. So as the name suggests, this particular pruning is it will help us in avoiding the overfitting of the test data also. Yeah. So moving on to question 4, when can the process of constructing a decision tree be stopped? Yeah, so this you can answer to this particular question. You can give me based on your common sense as well. What do you think? Because we have discussed the hierarchical this thing also, that the classific that what clustering Agnes and all those things, top down and bottom up. So at that point we had discussed this in detail, when to start and where to stop. So if you recall, because decision trees are also very similar to that, instead of just based on a given data set, we'll use it for prediction as well. So mostly I'm getting correct answers in the chat box. So let me tell you, this particular question has more than one correct answer. So of course, as most of you agree, option A is correct answers, because when there are no more condition left, we don't have to add new conditions or new nodes to our existing tree. So at that time we can stop. Okay. And yes, Minuta, you're right. And when all the conditions belong to one group, at that time also we can stop, because we don't need to unnecessarily increase the complexity. You remember pruning, what in last question we discussed, we will remove the less significant nodes from our decision tree. If those those sub nodes or sub decision trees are also leading to the same group at the end, then we can club them together and have one there are two conditions based on this. Suppose percentage attendance. Attendance is greater than 50 and attendance is less than 50. So people having attendance less than 50 will fail in the exam always. But people who, because they are not allowed to sit for the exam, and people who have attendance greater than 40, they may pass or may fail. But since these people are not writing the exam altogether, so we have removed this one node, we have pruned this node of pass and fail and put everyone in the fail. And here there are two, this node, there is also one decision which is to be made here, either pass or fail. So this is what it means then when all the conditions belong to one group. So then also we can stop. There is no further division here at this particular point, there is no node added. This becomes the leaf node. Yeah, so both option A and B are correct. So moving on to next question. So we had discussed this concept of ROC curve, where we calculate area under curve. You remember in initial weeks we had seen confusion matrix and all those parameters in second or third week, I don't remember exactly. Yeah, so at that time we had discussed how we how we choose the suitable algorithm, suitable ML algorithm. And even without explaining, I'm getting all the correct answers in the chat box, so you all remember that means. Okay, so we will consider whenever ROC curve, we'll consider area under the curve, and the algorithm which has maximum area under the curve will be chosen. Yeah, that will be considered as our final model. So there is again voice break. Is it for everyone, or it is for Vinuta only? Can you guys type in the chat box if my voice is breaking? Okay, okay. So Vinuta ji, there might be some issue regarding network from your end only. Yeah, because it seems that for others, it's fine. It seems. Yeah. So as we were discussing area under the curve, so we will be looking out for. We will be. So is it echo for everyone, or it's normal? Because to avoid that, I'm using the headphones and other things. So it might be some normal only. Okay, great, great. Because Varun ji has some echo at his end. Okay, so these might be some local issues, it seems, because for others it's normal. Yeah, so we'll choose the algorithm which has maximum area under curve. Yeah, so can you tell me which graph has, or which thing has the maximum area under curve? I have zoomed in onto the graph. So this particular blue line is for random forest. Then this dotted line here is the logistic regression. This green line is KNN. This particular line is KNN, and this is the reference line. Yeah, this is the logistic regression, and this is the random forest. Yeah, so blue line random forest has the, this seems to be the maximum value. So yes, going by the value 0.94 as ROC. Correct. So the correct answer for this particular question is random forest. Yeah. So moving on, how is root node chosen in the decision tree? Yeah. So I will read out all the options, and you can tell me what you think would be the correct answer. Okay, how the root node is chosen? It is randomly chosen. Option A says. Option B says the node having highest entropy is chosen. The node that is positioned in the middle of all nodes is chosen, and D is node having the highest information gain is chosen. Only one correct answers, no two correct answers for this particular question. There's only one correct answer. Yeah, so most of you have given correct answers. The highest information gave, which gives us the most information about our data distribution and the probability and everything. We will be choosing this. And as the name suggests, information gain. And entropy is the, as you know, the word suggests, entropy is the degree of variation of the in your data, to what degree your data can vary. So this will not be, entropy will not be choosing our root node or anything, but instead information gain will decide. But the formula for information gain is also dependent on entropy. Yeah, so even though we don't consider entropy, we consider only the information gain to decide what particular node is going to be root node for our decision tree. Okay, so moving on to numerical question. So there's this table. A researcher is trying to identify root node to design a decision tree classifier to classify the students based on score greater than or equal to 50%, which is pass or which is fail. So if a student scores greater than or equal to 50%, that particular student is pass. Okay, so we will, and who score less than 50 will fail. Okay, so let us try to assign the pass or fail. So this particular student will fail because why? Because less than 50% is fail, and greater than or equal to 50% is pass. So rest of the students is pass. Yeah, so that means this is 2 divided by 6, not 7, sorry. 2 by 7, and this is 4 by 2 by 6, and this is 4 by 6, you know. So probability, yeah, probability of pass and probability of fail we have here. Hmm. So now this is less than 70, more than 70. So this total is 5, and here this is 2. Hmm. There are two groups for every feature. Yeah, there are two groups for every feature. So let's try to do this counting beforehand. Okay, so more than 30, more than 3 hours of study time, 4 count, and less than 3 hours is 2 count. Yeah, and less than 5 assignments completed, 3 people have completed less than 5, and 3 people have completed more than 5 assignments. Okay, so we'll just quickly do this counting calculations. Oh, yes, thank you. Thank you for pointing it out, otherwise it would have impacted our further calculations. Yeah, so now let us go to the question and see what is asked. Yeah, entropy of the target column. Yeah, so our target column is this, because we have to predict pass or fail, na? So this seems to be our target column. So let us see the formula. Let's just try to copy the formula. Yeah, here's the formula given: pi log pi summation of, so there is minus sign missing from that formula. Okay, that screenshot formula, minus summation of minus pi log pi. Okay, so it is, let us try to pi log pi. And what will be the base? How many classes are here in our target, like a result? How many classes, pass or fail? So how many? 2 classes. Yeah, so we'll have to do this calculation to the base to 2. Yeah, log to the base 2. So now if you see, this probability or p value is 2 by 6 and 4 by 6, no? P of fail is 2 by 6, and P of pass is 4 by 6, which is 1 by 3.33, and this is 2 by 3, which is 0.67. Yeah, so now let us do this one thing: minus 0.33 into log to the base 2 of 0.33, minus, because this is minus summation. Okay, so minus 0.67 pi into log to the base 2 0.67. Yeah, so we have to calculate this particular value. Okay, so let me go to log calculator. Yeah, so I've already, yeah, so this is log to the base 2. Yeah, log to the base 2. Our x value was 0.33. Yeah, so this is minus 1.5995. So can we round it off to minus 1.6? Yeah, so let's switch to our notes. This is 0.33 minus 1.6. Let's keep the negative sign here. So this negative will become positive. Yeah, so let's do this calculation: 0.67 multiplied by log to the base 2.67. Okay, so let's go here. Instead of this, what we'll do, यहाँ पे 67. Yeah, so minus of 0.5, let's round it off to 0.58. Yeah, 58, let's consider 58, or we can do it 0.6 also for simplicity. Let's do it 0.6 so that it becomes 0.67 into 0.6. Yeah, so now I'll open my phone calculator. and do this. You can also do this and let me know. Okay, was there negative sign for this? Yes, there was negative sign for this. This is negative, so this negative will become positive value, and यहाँ पे भी it will become positive value. Okay, so 0.33 multiplied by 1.6 is 0.528, and 0.67 multiplied by 0.6 is 0.402. Now we just have to add these two values, which is roughly 0.93 is what I'm getting. Yeah, which is, yeah, because we did this na 0.5658 ko something we considered 0.6, so that's why we are getting 0.93 for ease of calculations. But yeah, so nearest option, so this would be the correct answer, 0.92. Yeah, so you understood how this is to be done. Now you know with the how to put the values in the formula. So easy hai, don't get confused. You just have to use log to the base 2, because mostly we'll have the binary classification. Binary classification as in there'll be two classes, not more than two. If there are more than two, then of course you can add, it becomes similar, but instead of log to the base 2, it will be log to the base 3. Yeah, so same thing you have to repeat. I mean, yeah, add similar thing. Yeah. Formula, yeah. Yeah, but this negative sign is inside summation na, so when there is negative sign inside, when you add negative values, it is like subtraction, you know. There's a minus sign before every term, like p log p, the term which we are calculating, there'll be minus sign before that. So even though we are adding, I did not get your question, can you elaborate me? And minus sign, yeah, so it's like addition of negative values is as good as subtraction, so that's why there is this minus sign. And this could be, if you call this term as a and this term as b, so it is like minus a minus b. It can be written as minus a plus minus b, no? So see, this formula says summation minus this is one term, you know. So if you call it as entropy, yeah, let's consider it as E. So this is the formula, like summation of minus E. Yeah, yeah. So this A and B is expansion values to this. Yeah. So what I'm doing is this, there is a negative sign in front of this term, no? So this is minus negative sign in front of this term, because there is, here is negative sign that comes here and here. So the expansion of the summation minus E is like minus A plus minus B. You agree to this? Minus A plus minus B is expansion of this negative summation. So I simplified it as minus A minus B. It can be done like that, right? You agree? Yeah? So this thing I've done here, I skipped that step of minus plus minus minus. I thought, yeah, let's skip that and add minus minus minus. Yeah, yeah. Okay. So, should we move on to next question? Yeah, let's move on to question 8. Question 8 says, which of the following parameters is considered as root node? Yeah. So there's now is the fun part. Okay. Now you have to root node. What was the criteria for root node, if you remember? Entropy or information gain? Information gain, right? You remember we had discussed just a question before that. Yeah. So we have to calculate information gain. Yeah. So what information, now let us come to this particular thing. Okay, so we have to, like, here was the formula. So no, not formula, here is the probability of a particular class pass or fail. Yeah, so what we will do is we will try to find this probability for every class, for every this feature. Here it was target feature. Yeah, we wanted to have target. Now we have to do it for every feature. Yeah, so if you recall the entropy formula, not entropy, sorry, this gain formula says, yeah, information gain is a S is for given entropy. Yeah, S is entropy, and A is any feature or independent variable. Yeah, that particular independent variable. So this is probability or the count of the classes of in that particular feature, for that particular feature, you know, what are two different classes for that particular node. Hmm? So this SV and S is probability of classes for that particular node. If there is attendance, then what is the probability of students having attendance greater than 70%, or what is probability of having attendance less than 70%? And then entropy, the respective entropy we have to do. Okay, so remember this formula. So formula says entropy minus this probability thinking. Yeah, entropy S minus there is SV by S, which is the class count, and entropy of SV. Okay, so this entropy, for ease of calculation, remember that formula for probability value 0 to 1. What is the entropy value? Is it maximum or minimum? Yes. For 0 and 1 it is 0, right? Minimum value of entropy. And for probability of 0.5, what is the value of entropy? You remember that graph? 1. Yeah? Yeah. So we will have this information handy that will help us in getting this particular entropy value. Okay? So this is the formula. So now number of assignments completed. Let's go to number of assignments completed. Yeah, so there is 3 out of 6 and 3 out of 6. Yeah, so 0.5, 0.5. So this value is SV by S. Okay, this value is SV by S. You remember I had told you, like, this formula, this SV by S is number of count or in that particular class for that particular feature. Okay, so this SV by S value is 0.5 for number of assignments completed. And now comes the tricky part, how we will calculate the probability which is to be used for entropy. So in that, what we will do is we will see out of these 3 how many are going to fail and how many are going to pass. What is the pass probability out of these 3? Out of these 3, how many are passing? Only this one, right? So for them, the p value for this particular group is 1 by 3. People who have less than 5 assignments completed, out of all the people, how many are going to pass? 1 out of 3. Yeah, so the p value is 1 by 3. And for the people or for the students who have completed more than 5 assignments, how many are there? 3. Out of those 3, how many are going to pass? Can you check the last column with corresponding row? How many are going to pass out of those 3? All 3 are going to pass. P, all 3 are passing. Yeah, so 3 divided by 3. So this probability here, what will be the probability for this assignments more than 1? Assignments more than 5 assignments completed. this group, what will be the probability of passing? There are these 3 students, all of them are passing. I'm going to link, I will be removing this link. Yeah, so all are passing, whereas out of these 3, how many are passing? Just this one last student. So for this group, the probability value becomes 1 by 3. Is it clear? Yeah. So there are these 2 different terminologies, na? SV by S. Yeah. So SV by S is division of classes based on that particular feature. So for number of assignments completed, we have 2 classes, less than 5 and more than 5. Yeah, we have total sample size 6. So out of these 6, how many students had less than 5 assignments completed? 3 by 6. So this SV by S is 0.5. Similarly, how many students, or what is the probability out of 6 more than 5 ka? Similarly 3 by 6, 0.5. Yeah. So now for entropy, we have to consider with respect to our target feature. Our target feature is marks out of 100. Yeah. So out of these 3 students who have less than 5 assignments completed, what is the probability that the student will pass? How you will get that? No. Look at the last column. Marks out of 100. 50. So I have already written this, na? Pass, fail. Yeah, 1 by 3. Yeah. So p value here is 1 by 3. Now similarly, what is p value for assignments completed are more than 5? Can you tell me? All are passed. So what is probability of passing? When you have more than 5 assignments finished or completed, what is the probability? If all are passing, that means what is the value? Number, I'm looking for that number. Probability 1, you agree? Yeah. So for this, probability will be 1. So for probability 1, what is the entropy value? 0. Yeah. So when we write this SV by S into some E1, entropy value is 0.9. We'll consider this 0.92, whatever the answer we have gotten. Yeah. So 0.92 minus this, and I'm opening the bracket. So instead of this will be for class 1 C1, and this will be for C2. This will be the expansion of this formula, entropy formula. Okay. So now SV by S ka value is 0.5 for number of assignments completed, and for this probability 1, the entropy value is 0. So this term, the entire term, because this E2 value is 0, this entire term will become 0. So now 0.92 minus SV by S क्या था अपना 0.5, yeah, 0.5 into, we need to now calculate entropy for this 1 by 3. Yeah, so what we will do is 1 by 3 is 0.33, and 2 by 3 again, you know, the same thing, pass and fail. जैसे यहाँ पे two values had come, same cheese we'll have to do, minus 0.33 into log to the base 2.33. So this will be the entropy value for that particular class, na? So this, so how we will do that? 0.93 into 0.05 into this entropy value 0.92, right? 0.92 multiplied by, one second, 0.92 multiplied by 0.5.46. So that will be 0.92 minus 0.46. So this will be the this value, and क्या बोलते हैं, information gain. Yeah. So now number of, yeah, it is minus. Yeah, multiplication is only here. Yeah, I've written minus only, na? Yeah. Is there some calculation? I mean, there could be. Yeah. So this entropy, we will calculate this entropy as this thing, no? Probability pi into log pi. Yeah. Minus summation minus pi into log pi. So pi is 0.33 for one class. So p1 and p2 would be 0.67. Yeah, because this is, no, for this particular one class we have to calculate entropy. So 1 by 3 and 2 by 3, pass and fail for both we have to calculate, no? So that's why this will be like that, 1 by 3 and 2 by 3. So if we put that 1 by 3 and 2 by 3 in the formula, I think the same value, no, 1 by 3 and 2 by 3, here we have already calculated entropy. So it comes to be 0.92 for this probability value. Yeah, यहाँ पे भी p value was 0.33 and 0.67, no? So that's why I reused that calculation, 0.92. So this entropy E1 becomes 0.92. So if you do 0.92, it comes out to be 0.46. That is how for this 0.46. Now number of hours studied, if we go on to number of hours studied. So this is very very simple. This we will do orally, number of hours studies. Yeah. So so this is 2 and this is 4. So what is SV by S? 2 by 6 for C1 and C2, this is 6, okay? And for C2 SV by S क्या होगा? 4 by 6. Out of this 6, how many students belong to class where number of hours studies are less than 3? 2 students. Do you agree? SV by S for this particular, let me change the ink. So this is, yes, this should be highest information gain. Let's come to that. Let's everyone be on the same page, you know. Will, yeah, 0 0 ho jayega, you are right. Yeah, for this it will be 4 by 6 and this will be 2 by 6 SV by S term. Yeah, we'll count how many out of the total sample size is 6. Out of 6, how many students are in the class less than 3 hours and how many students are in the class more than 3 hours? That is what I mean as by SV by S. So 2 by 6 and 4 by 6. So now out of these two students, how many are, what is the passing percentage? How many students are going to pass? Can somebody tell me? I will not say unless somebody unmutes and responds. All are fail. So what is the passing percent? If all are failing, how many are 0, right? So probability for this would be 0. So if probability is 0, what will be the entropy value? Yeah, we had noted here for p value 0 and 1, what is the entropy value? 0. Yeah, so this term will be 0. Yeah, for first class. Now the second class, which is number of hours studied more than 3 hours. What is the probability of passing for these 4 students? 1. So what will be the entropy? 0. So this term will again be 0 for second class also. So this entire term will be 0. So what will be the information gain? Here I will write it here. What will be the information gain? See the entropy value, yeah, which was 0.92. Agreed? Everyone on same page? Yeah. So as I we discussed this probability and entropy ka there is one connection. Okay, I think you have missed the initial part of discussion, that's why you are getting confused. Okay, so when I was explaining this formulas, at that time there is so if you are interested in more, you can look on YouTube or any other source on internet on this explanation how this comes and why this comes. So I'm not going to go into why and how, but instead I'm going to point out that you need to remember, okay, there is this relationship between probability and corresponding entropy. So here is probability on x-axis and entropy value on y-axis. So when you have probability of an event or a class occurring as 0 or 1, the corresponding entropy is always 0 for 0 and 1. And when probability is 0.5, the corresponding entropy value is 1, which is maximum value. Okay, yeah, this you followed. So you have to remember, when probability of a particular class occurring of particular class is 0 or probability is 1, then their corresponding entropy will be 1. So when we are and when corresponding entropy is 1, then this formula, this entire summation, even if the one entropy is 0, this entire summation will become 0. Not entire summation, that particular value will become 0. Yeah, that particular class, for that particular class there are two classes always for all our sums, for ease of calculations. So the value, this value summation, the entire that chunk of whatever the terms, that one number will be 0. Yeah, so for that class this particular value will be 0. So in this case, what was the feature? I forgot. Yeah, number of hours studied. In this case, for this part, for both the this thing, for number of hours studied which are less than 3, all of them are going to fail. That means none of them are going to pass. So probability is 0. So entropy value was also 0. So that summation wala term was 0 for this less than 3 hours class. Now come to more than 3 hours class. In a class where students are studying for more than 3 hours, all of them are passing. That means passing probability is 1. So when passing probability is 1, the entropy value is 0. Yes, so this entropy value is 0. That means this entire summation block is 0, because for both the classes that value was 0. So that means our information gain was equal to entropy S, which was 0.92. So that is how this entropy comes to 0.92. Yeah, and marks out of 100 cannot be root node, because that is our predictor, our target or the predictor variable or the target variable. So this becomes out of question. So now attendance percentage. Okay, so now looking at this distribution, can you tell me whether the attendance percentage, the distribution is 4 and 2, will this have entropy greater than 0.92? Not entropy, information gain greater than 0.92? Just by your understanding of formula and probability and entropy ka connection, based on your understanding, common sense, I don't need calculated values. You just have to tell me whether it will be greater than this, what was the information gain for number of hours studied. Will it be greater than 0.92? I have gotten just one answer. Okay, let me tell you. These are two classes. Let me again change the ink color. Okay, these are two classes. This is class 1 where attendance was less than 70%, and this is class 2, attendance more than 70%. Okay, so we'll call them C1 and C2. So SV by S for C1 is 4 by 6, everyone agrees, and C2 it is 2 by 6. So now for C1, what is the probability? Out of those 4, how many students are passing? I'm going to write here C1 के लिए probability. These are 4 students. What is the probability that for them, how many students are passing out of those 4? 2. These 2 are passing, these 2 are failing. So that means 2 by 4 is the passing probability, which is 0.5. And for this, more than 70, what is the passing? Sorry? Okay, fine, we'll ignore. Okay, for this C2, where students have attendance more than 70%, what is the probability? All the students are passing. That means what is the passing probability? P value 1. Very good. So for P value 0.5, what is the entropy value? E2 and E1. What is the E1 value? For 0.5, what is the entropy value? We have already written here. Yeah? 1. So that means this term will be SV by S. What was the SV by S for? 2 by 3. I'm sorry for that. So can you tell me what is the so this was 0.66 for C1. Yeah, so entropy value was 1. So SV by S was 0.66. So this becomes 0.66. So entropy value 0.92 for our predictor this thing. Yeah, then minus this entropy value is 1. So that means this becomes 0.67 for C1. Yeah, because entropy was 1. So our SV by S, which is written over here for class 1, that will be carried as it is, because it is getting multiplied by 1. Yeah, because the entropy is coming to be 1 for probability value of 0.5. Now for C2, the probability value is 1. So what is the entropy value? For probability value 0 and 1, what is the entropy value? 0. Everyone agrees? So that this entire term becomes 0. Yeah, this entire term becomes 0. So minus 0. So can someone tell me what is this? 0.92 minus 0.67. Yes. Yeah, so this seems to be right answer because 0.25. Okay, everyone got it? How we calculate entropy and how do we calculate learning gain? Yeah, so we will move on to next question. Calculate. No, it is going on. Recording is going on. Yeah, recording is going on. Yeah, don't worry, recording is going on and you all will have. It is already uploaded on YouTube. If you go to Swayam platform, on left hand side there should be a tab at the end called problem solving session. That should take you to a Excel sheet. Excel sheet has week wise collection of all the week's sessions YouTube link. Yeah. Yeah, we are supposed to upload it on YouTube. So we upload it on YouTube every week after this session, and then that link we provide onto that Excel sheet, and that Excel sheet is viewable by everyone who joins the course, and you can access that through the Swayam platform. Yeah, every week is there from week to week 8. Everything should be there, and this will go by tonight. Yeah, so we are supposed to upload it after every session. So I'm recording it on my local. I'm doing the screen recording from my laptop, and then it will go on to internet in some time. Okay, so don't worry, you will have access to the all the weeks this thing. Yeah. So we have already solved this. Calculate information gain for parameter attendance. We have already done this here. We already have the answer. 0.25, is it one of the options? Yes, it is. So so everyone understood how it came to 0.25? Yeah, because we saw here what was the s. So this was the sv by s. Yeah, sv by s, first term of that formula, that thing. So this was 2 by 3 or 0.66 for C1, and 2 by 6 or 1 by 3 or 0.33 for C2. But probability of passing for C2 was 1, whose entropy was 0, hence the entire term became 0. Now coming to SV by S into entropy, for that we calculated probability of passing for this C1. Out of the 4 students, 2 are passing, 2 are failing. So 0.5 was probability of passing. So for 0.5 probability, entropy value was 1. Hence that whole term became SV by S only, which was 0.67. So this we subtracted from the entropy value. So entropy, यहाँ पे entropy value 0.92 minus 0.67, and this 0 is that because of that entropy probability was 1, so entropy was 0, so the whole term becomes 0. The whole term became 0, and now this 0.92 minus 0.67 gave us 0.25. So this was the answer, 0.25. Okay. Coming to last question, consider following statements. Naive Bayes assumes independence among predictor, and naive Bayes can perform multi-class prediction. Which of the following statements are correct? Okay, why you think second one is not correct? Yeah. Yeah, that's true. Yeah, you're right. Second one is also correct. Base one, yeah, base is not necessarily binary. Yeah, we can use it for multi-class classification. Any decision tree, we can use it for multi-class classification. Yeah, and it is the naive assumption that all the predictor or all the independent variable are independent of each other. They don't influence each other. So both the assumptions are correct in case of naive Bayes theorem. Okay, so we are at the end of assignment. So if there are any doubts, we can take them up. Or you want me to repeat something? It is already shared, so you guys have not been checking Swayam, it seems. Okay, so Swayam, yeah. So Swayam has, if you see on left hand side, you have week 1, week 2, week 3, week 7, week 8, week 9, week 10 written, na? The content. When you go to course, so at the end there is one of the end or second from the bottom, I don't remember, there's a link called a tab called problem solving sessions. So if you, that's what I'm telling you how to get that. So if you click on that problem solving session tab, there will be on main portal. Yes, of course you have to go to course. Yeah, so Shrinanda has shared the link to, I think, Google Sheet. Yeah, that Google Sheet where I update every week. So this Google Sheet has link to the PDFs which I use during our discussions, the annotated PDF. Yeah? Yes. So if you open that, which is shared by Shrinanda, if you open that link, there's spreadsheet link, right? So if you go to that, yes, because today is week 9, so this is still going on. This will go after our session gets over. After that, it will go on to YouTube, and I will update the link on the same sheet. Okay. Yeah. So this sheet has both thing. This has a presentation folder link. If you go, you will see all the PDFs, the annotated PDFs which I use for the discussions. That is part of that folder. So you can refer to that also, and there is this column where YouTube this thing is mentioned, that is also part of that. All the YouTube recording, yeah, not YouTube recording, recording uploaded on YouTube. Yeah. So not, this is not part of announcement folder. That was I was trying to tell. So there is a tab called problem solving sessions. Okay, where the week 1, week 2, week 3 comes. No, left hand side tab. Yeah, yeah, there is that problem solving tab. If you click on that problem solving tab, there is this uh, link will come. Link to this Google Sheet. All are supposed to show. Yeah, yeah. Yeah, it will be visible. Okay, so did you try opening this spreadsheet which Srinanda has shared, and still? Okay, 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 okay. So if you get access to that one video, no? Yeah. Yeah, yeah. So no, no, not current year. They will not give, Ray. Most of the questions are common, so if you follow this now, this assignment solving session, you will be yeah, you will be able to solve this also. Yeah, I mean current year's assignment also, but I am not supposed to discuss current year's assignments in this session. Yeah. Yeah, yes, Srinanda. Yes, 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 yes. Log to the base 2, log to the base 2. So yeah, so we can log of 0 to the base 2, because if you notice now, all the node will have just two leaves in our examples everywhere, you know, every feature had just two this thing, you know, two classes. That means for based on every feature there are two classes possible. The decision will be either be yes or no. Yeah, but there could be multiple decisions, you know. So if you plot log to the base 2, so like we have this log wala over here. ठीक है, so let's see for ठीक है, log 0 is undefined. हाँ हाँ, yeah, yeah, so let's do the limits wala thing. Let's check for log to the log 1 to the base 2 is 0. Yeah? And now let us do 0.001, which is negative value. ठीक है, 0.01, 0.1 minus 3, 0.2, 0.3. There'll be somewhere it will be coming to this thing. So but if you, that's why let's not go into mathematical derivation or anything, you know. So 0.9 ka, it is almost 0, minus 0.01, right? So you agree it's almost 0. Yeah, so let's not get into the mathematical part. Let's just keep in mind for probability value 0, because it is locked to the base 2. So that's why it is, you know, 1 by 2 पे maximum value देगा. 1 by 2 is 0.5, 0.5 पे maximum value देगा 1, because it's to the base 2. That's why the bell curve is also symmetric, because it's log. And yeah, so that's why. Yeah, that's why we are not going into derivation and why this bell curve. That's why I'm pointing out, okay, let's remember, just remember. This one, yeah. So this was not. See, I'll tell you, this was not complex at all. I mean, if you trust me, we did attendance percentage. We could actually yeah, do it without much of this thing, because probability values which we are calculating, probability of pass and fail, these were actually, most of them were actually that na, either point 0.5 or 1. So the whole term becomes 0, or the whole term becomes 1, so whole term reduces to just SV by S. Huh? So most of the times that was happening. I think the only calculations we did was for this first, no? Here only we did most calculation. This also becomes, the entire thing became 0, so it came out to be entropy value for number of hours. So these were not complex calculations. These were very easy. Only for one which is done over here is where we did calculations. This was the only calculation part which we did, where we actually calculated entropy like this, and yeah, here entropy calculation we did, and then did multiplication. So this entropy calculation was also done in this step, because the probability values were same. Yeah. So we did not do any kind of complex calculations here. So Shrinanda, don't worry. Right. Yeah. So remember this, for what probability value entropy is 0 and 1. I think mostly all the concerns will be solved, taken care of by there only. Yeah. So Shrinanda, don't worry if such problems come, then you will be getting log values, or you will be provided with the values or log table, whatever is applicable. So don't worry about that. You don't have to buy hard log ka table, yeah, log to the base 2. Don't worry about that. Yeah, in school we used to do that. Yeah, maybe scientific calculator will be allowed. Non-programmable one. Yeah. 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 And mostly, if such questions are coming, then we'll try to provide the values also, log to the base 2 ka values. So other calculations are easy. Hmm. That's so nice. Yeah. That's so nice. Thank you. Thank you for informing all of us. Yeah. Thank you. Log to the base 10. Yeah. Hmm. Hmm. Yeah. Yeah, so please remember these pointers, very nice pointers shared here with us. Thank you, Krishnaji. No, so what he said is, we are given in exam, you will be given with the online calculator, which will have log function also. So you have to be careful to use log to the base 2 and not log to the base 10. Yeah, so you have to be careful which log function you are calling. Yeah, so that was the point. Yes, yes. Yeah. Okay. Yeah. Yes, Shreya. A 7 we did so many times, Ray. 7 I am not going to repeat now. So many times we did. Here is step by step calculation how we came to this. Okay. 7 I'm going to just tell you. This is the two classes ka probability, fail ka probability, pass ka probability. This is number we have. Just putting these values into this formula to calculate entropy. Here comes the formula. The values have been put and we have gotten the answer. Okay. Yeah. I'm not going to repeat this. Some 3-4 times we have repeated these calculations. Okay. Sorry, Shreya, but I don't want to do that once again. Question number 2, we can take it up. So again, question number 2, since this is log to the base 2. Okay, this is pi log pi. This is to the base 2. So Yes, yes, log to the base 2. And you have to remember this graph, this will come in handy for calculations for what value of probability for 0 and 1, this entropy value is 0, and for probability 0.5, entropy value is 1. So it is the same question. Yeah, the P is probability and C is number of classes. So C is number of classes which is log to the base 2. Now entropy is maximum and minimum value. So these are the facts, these are part of the lecture also. If you go to watch the lectures, this is covered in the lectures also. Yeah? So maximum value is happening at 0.5 which is 1, and minimum value at P 0 and 1 which is 0. Yeah, so it is kind of fact for this particular course for calculating entropy. When probability value is 0 or 1, the entropy becomes 0, and for probability value 0.5, entropy value is maximum which is 1. So probability value entropy value also lies between 0 and 1. For probability 0.5, entropy is 1. For probability 0 and 1, entropy is 0. Okay, so entropy gives us, entropy suggests the randomness, it is based on the randomness of the data. If the data is random, we'll have maximum entropy. And if data is not random, then entropy will be minimum. So how you will get data is random or not random? Based on probability. So when you for sure that your data belongs to this particular class or does not belongs to this particular class, that means the probability will be either 0 or 1, right? When the data is not part of any class, probability is 0. When data is all the data points are part of that particular class, then probability is 1. So when there is certainty in your distribution of data, at that time entropy will be minimum, that is 0. When there is uncertainty in the data, the distribution, the probability that data would belong to either of class, that is 0, the value is 0. Like when you have probability of pass or fail is 0.5, like tossing the coin, it could be heads or tails, the equal possibility. So pass or fail, equal possibility. So when there is equal possibility, that means 0.5. This also can happen, this also can happen, there is equal probability of happening. That means 0.5. The data is random at best. That for random at best, the probability value is 0.5. So the entropy value will be maximum at 0.5. Yeah. I don't know, maybe you should ask Professor Ramkumar whether he will be offering maybe advanced machine learning for learning analytics or. Yeah, but not from a learning analytics point of view. No, we do a lot of things like multimodal learning analytics, and yeah, there are so many things. Yeah, yeah, not offered in NPTEL. Yeah, yeah. I mean, yeah, we do many things which are not part of this course also. Not in learning analytics. We have MTech program in educational technology, EdTech. Like our department offers MTech program as well. Yeah, this is, yeah, learning analytics is one of the core courses of MTech program. Learning sciences, learning analytics. It is kind of, yeah, and yes, yes, design learning. Yes, yes. So we do a lot of interdisciplinary work. Yeah, so Varun has shared the online calculator which is given during NPTEL exam. So if you want to be confident, you can practice using this calculator. You can resolve the questions which we discussed. So you already know the answer and you know the procedure. So you can repeat the same questions on your own, so that you get the idea of which values goes where and how to come up with the entropy total value. Yeah. So practice, and as Krishna ji pointed out, no, don't use decimal log, use log to the base 2. Okay, otherwise your values will be wrong, the answer will be wrong, and even though your calculations will be correct, you will not get correct answer. Yeah, so I think we can close today's session. We had wonderful discussion today. Hope to see you next week. I'll close this session. Okay, yeah. Okay. See you next week. Huh? Thank you. Yeah. Closing the call now.